Now let's look at one more question on the concept of friction head losses in pipes before we move on to the next topic and talk about the minor losses in pipe. So the question says we have an oil of specific gravity 0.9 and the viscosity is 0.06 poise. It is flowing through a pipe of dia 200 mm at the rate of 60 lps. Find the head loss due to friction for a 500 mm length of pipe. Also find the power needed to maintain the flow. Okay, so let's write on the given data first. So the specific gravity is 0.9. This makes the density of oil as 900 kg per meter cube. The viscosity is 0.06 poise, which means it will be 0.006 Pascal seconds. So you add one more zero. Okay. Now the discharge is given 60 lps. So Q, we have Q as 60 lps, which means it is 0.06 meter cube per second. Okay, you have the dia of the pipe. So dia of the pipe is how much? 200 mm, which is 0.2 meters. So this gives us the area as pi by 4 into 0.2 square. Now with Q and with V, with A, we can find out the velocity, that is V, which is Q upon A. So Q upon A, which is 0.06 upon pi by 4 into 0.2 square. So this will come out to be 1.91 meters per second. Right. So now I have density, I have mu, I have d, and I have velocity. I can use it to find out the Reynolds number because we need to find the friction factor. So let's first of all find the Reynolds number, which is Vd rho upon mu. So V is how much? 1.91, d is 0.2, rho is 900, and mu is 0.006. Okay, this will result in a Reynolds number which is 57,300, which is very higher than 4,000. Means the entire flow is turbulent. So for turbulent flow, the friction factor is 0.0791 upon a Reynolds number to the power 0.25. 0.25. Okay. So you put in the values, you put Reynolds number as 57,300. This results in a friction factor of 0.0051. So with the help of this, I can now calculate the head loss due to friction. So you have 4FLV square upon 2 into G into D. This results in a value of 9.48 meters. So this is the head which is lost in friction. So how much power do we need to maintain the flow? That is, we have to overcome this frictional head loss. That power would be rho Qg into Hf upon 1000, and that would be in kilowatts. So rho is 900, Q is 0.06, gravity we all know, Hf is 9.48 upon 1000. This gives you a value which is 5.02 kilowatts. So you need 5 kilowatts approximately to maintain this flow, which keeps on losing 9.48 heads or meters of head loss due to friction. So I hope you understood this entire numerical on the friction head losses in pipes. Now let's look at some minor losses in pipes.